Let's now extend this to examine the wedge. What if we're dealing with a statement like A or B? So again, we'll go line by line here, and I'll try to do this fairly quickly. What if we have T or T? To use the same example, suppose that I tell you, either I'll give you an A in the first test, or I buy you dinner. I'll do one, I say, or the other. And as it turns out, I actually follow through on both of them. I give you an A, and I buy you dinner as well. Well, have I told the truth? Was I honest with you? And of course I was. In fact, I went over and above. I said I'd do one or the other, but as it turns out, I did both. So of course, the value of my overall statement is in fact true. What, however, if I say I'll do one or the other, and as it turns out, I actually only do one? I only do one. Have I been honest? Well, here too, the overall value is going to be true. I said I'd do one or the other, and as it turns out, I do the first one in line number 2, but not the second one. Well, I've told the truth. I didn't say I would do both. That would be the dot. I only said I would do one of them. What about line number 3? Does the ordering of the T's and the F's matter here? In line number 3, the first disjunct number 1, make sure you get the vocab straight, disjunct number 1, disjunct number 2, when we're talking about a dot, conjunct number 1, conjunct number 2. If the first disjunct is false and the second disjunct true, what's going to be the overall value? Does, in other words, the order of the T and the F matter at all? And as it turns out, it doesn't. It doesn't. Both of those turn out to be true. Both 2 and 3 turn out to be true. Leaving us now just with line number 4. What if I said I'll do one or the other, either A or B? Either I'll give you an A or I buy you dinner. And as it turns out, I fail to do either one. If we are stuck with F or F, the overall truth value of the wedge statement turns out to be false. So once again, there are 4 possible combinations here and 4 different possible answers, but only concern yourself with the exception. The only way for a wedge statement to be false is if both disjuncts turn out to be false. In other words, if one or more of the disjuncts is true, then the overall truth value turns out to be true. So that's the wedge. Let's now turn our attention to horseshoe statements. What if this time we have A horseshoe B, if A then B, if A then B. In line number 1, we'll say again A and B are both true. If this turns out to be the case, both of the variables are true, then the overall truth value is true. And if you take a little time to think about it, probably makes perfectly good sense. Just to drive home the point, let me now plug in some different propositions for A and B respectively. What if I said something like this, just to use a generic example? What if I were to say, if the sun comes out, then it will be hot. If the sun comes out A, then it will be hot. And as it turns out, a few hours later, the sun does come out, and after the sun comes out, it warms up a bit. It actually does get hot. If I say, if the sun comes out, and it will become hot, and both A and B are true, then the overall truth value, of course, makes perfectly reasonable sense, perfectly good sense. The overall truth value is T. What, however, if A is true and B, the consequent, is false? What if we have T horseshoe F? To use the same example, what if I say again, what if I were to say, if the sun comes out, then it will be hot. The sun actually does come out, but it fails to become hot. Well, here, under these conditions, I have not told the truth. I was wrong. I was wrong about what would occur. I said if the sun comes out, it will be hot. The sun did come out, but it didn't become hot, and so it was false. Leaving us now only with 2 lines to examine, lines 3 and 4 respectively. What about F horseshoe T and then F horseshoe F? Well, under both conditions here, the overall truth value turns out to be true. Now, what's the explanation behind that? That seems a little mysterious, particularly this 4th line here where both of them false. If both of them are false, how can it turn out to be true? Well, let's use our same example here. I say in my original statement, if the sun comes out, then it will be hot. In both lines 3 and 4, the antecedent, the initial condition, is not met. If the sun comes out, it'll be hot. But let's suppose in both of these lines, the sun never comes out. The sun does not come out. Well, in that case, the actual conditions, what actually takes place, doesn't really apply to my original statement, so we'll consider it to be true. Again, only memorize the special case. There's only one way for a horseshoe statement to be false, and that's when the antecedent is true and the consequent is false. T horseshoe F is F. All other logically possible combinations are true. Let's now go on to the triple var. What if we have A triple var B, A if and only if B? Language again quite similar to the horseshoe, but slightly different meaning. A if and only if B. Well, here too there's a shortcut. If both variables have the same truth value, if for example they're both true, then the overall value turns out to be true. If they're both false, again, same truth value, then again, they are true. If, however, we have a mixed bag, one's true and the other's false, or vice versa, one's false and the other true, then it turns out to be false. So that's the shortcut for the triple var. If it's the same value, it's true. Both TT or FF, it's true. If they're different, one T, the other false, it's false. So that now just leaves us with one other operator to go, and that's the tilde. The tilde is different, as you recall, from 6.1 for a number of different reasons, and so our truth table, when it comes to the tilde, will be slightly different as well. Instead of having 4 lines on our truth table, we'll only be stuck with 2, and so the tilde here is a little bit easier, which is why I've saved it for last. The tilde only negates the variable that it comes directly in front of, not A. So here we're just dealing with a single variable, again, meaning that we'll only have 2 lines in our truth table. Given that we're only dealing with a single variable, and the variable again stands for a proposition is either true or false, there are only 2 logically possible combinations, either A is true or A is false. So what if A is true? What then is the value of not A? Well, it would be just the opposite. It would be the opposite. If A is true, then not A will be false. If, however, A is false, then not A will be true. Not A will be true. So, long story short here, to solve for the tilde, just go with the opposite of whatever it is that you start with. If you start with true, then it becomes false. If you start with false, then it becomes true. So the tilde, easy enough to deal with, easy enough. And those are the truth tables for all 5 operators. And this again will serve as the foundation for all of Chapter 6. So you'll certainly want to commit this to memory. We'll be using these for every section in the chapter, and we'll be solving quite a number of problems. So trust me, it'll make your life much, much easier if you take a little bit of time to memorize the truth tables for all 5 operators. But again, just concern yourselves with the shortcut. One way for a dot to be true when both conjuncts are true. Only one way for a wedge to be false when both disjuncts are false. Only one way for a horseshoe statement to be false when the antecedent is true and the consequent false. The triple var, easy enough. If it's the same, they're true. If they're different, it's false. And then the tilde, just flip it.